All right. Welcome everyone to today's Let's Profile. Looks like we've got a nice number of people in chat already. That's awesome to see. Welcome everyone. As always, let me know if the background music is good. If you ever want me to increase the font of anything in my terminal, in my browser, let me know. Welcome everyone in chat. Glad to see you back in the chat. Hopefully today we can optimize the OpenTelemetry Collector a little bit. For those that are maybe new to the stream, welcome back, Nicholas. For those who are new to the stream, the way this works is we basically take some random profiling data of something that we happen to run in production at Polar Signals. And something that we would gladly do in the future is if you take some profiling data with, let's say, the Parka project or with Polar Signals Cloud, and you share it with us ahead of time, then we can consider looking at some other pieces of infrastructure or applications or whatever. I think what I value is that it's actually production profiling data, so that this is not some hypothetical improvement that we're making, but this is actually going to make a real impact for real production environments. So with that said, what we're going to be looking at today, again, is the OpenTelemetry Collector. For those that are maybe not familiar with this component, in the OpenTelemetry ecosystem, and the way that we happen to use it at Polar Signals is exclusively for distributed tracing. We use just a logging system that picks up logs from disk from our Kubernetes containers, and Prometheus for metrics. So we only use it for distributed tracing. And so everything that we're going to be seeing is only going to be relevant for those parts. So I don't know, there may be other configuration that this has more or less impact on. The point is, this is going to be, hopefully, we'll find out if we're actually going to be successful. This is another piece, if you're new to the show. We don't look at this data. We don't look at the code ahead of time. We have no idea whether we're going to have an impact or how large that impact is going to be in reality, or once we try to make our changes. There have been times where we made almost no improvement, or it looked for a long time like we were actually going to make it worse. So it's kind of a roller coaster. We'll see what happens today. All right, like I said, if there's anything about, oh, and let me adjust my microphone actually. Hopefully this sounds a little bit better. If there's anything about the font that you want me to change, if there's anything about, anything that you think could make the stream better, let me know, and I'll try to implement. All right, now without further ado, let's jump into the profiling data. So let's switch our scene here. Great. I gotta install some like sound. The room is actually quite echoey, and so maybe I need to get some sound panels to make this better now that we're streaming pretty regularly. All right, so let's start with exploring this data. So actually I prefer if we didn't dock it. So actually something that someone already mentioned on Twitter because I tried to post the profiling data ahead of time. Someone already mentioned that this particular set of stacks, the tail sampling processor, looks like it has a lot of opportunity for improvements, and the blue frames already kind of start to show this, because we can see here almost 3% are spent in some sort of memory allocation here. That's definitely quite a lot. We're doing, okay, this is probably not something we can do, but what's this over here? Something about a sync map accesses, probably okay. We see some more memory allocations, but they're pretty small in this case. Okay, this is an interesting one. This means that record with tags, I don't know exactly what that is, but it looks like whatever it's doing, this function basically, what this means is whenever we, I want to say we cast something from like we do a type assertion on an interface, that's like an empty interface, and we do a type assertion on it. I think this is the function that's being called. So maybe there's something that could be done better here. I don't know exactly. We should have a look at what record with options actually does in the code. But it both does this pretty expensive conversion call as well as a memory allocation. It creates maps as well all the time, it looks like. More memory allocation. So there are definitely plenty of allocations over here that, I don't know if they're necessary. Some memory allocations are good and necessary, right? Not necessarily saying that all memory allocations are bad or unnecessary. All right. So I think this is definitely a super interesting aspect of the OpenTelemetry Collector to look into. Let's see what else we have here. Stat view, interesting. I don't know what that is. And if you know, let me know in chat. If you know, this looks like it's something that's running in the background. Stats view. It looks like this is something that's running in the background all the time. And it's almost 10% of our CPU time. You know what? This might be the like /stats z endpoint or something like that, which I can turn off my screen for a second and check if we have that enabled in our configuration. And it may just be that we should be turning this off because we definitely don't use this. That's not a code change, but we've seen this before in our Prometheus node exporter episode. I forget which one it was, episode 2, 3, or 4, something like that, where the node exporter itself is actually pretty well optimized already, but it turns out there are a lot of collectors that are enabled by default, and we could see that there are a lot of collectors that just didn't make any sense. They were like BetterFS, for example, was enabled, and it's completely, we use 0 BetterFS in our infrastructure, so it was completely unnecessary that we were running that collector, even though it was generating a lot of CPU time. There's a comment in chat, would be fun if the health check probes cause load. Yeah, that's interesting. This OpenTelemetry collector is under a fair amount of load. There are several thousand requests per second coming into our main system, and that produces a bunch of tracing data as well. So this thing is definitely handling a fair amount of traffic. If every 10-second health check caused all of this CPU time, that would be pretty funny indeed. Let's go on. Over here, it's the bounded memory queue. Let's look at that. Looks like that's primarily about either accepting or sending out tracing data. We see this is all compression. Maybe this is another configuration thing that might make sense to use a different compression algorithm, something that we've seen and done many times before. Nicholas is saying in chat, compression seems to be consuming the majority of the CPU. Yeah, it does definitely look that way. We can also look at all this in the table view in a second, but I think you're probably right. Let's see, this is doing protobuf marshalling. So yeah, this looks like it's about sending off tracing data in a bounded memory queue. So here we've got some batch processor, which this is a tough one to optimize for. Basically, this is about just this is like a go select statement where we're waiting on something happening, like a for loop probably, and then a select statement within that. We have another comment in chat. Also, I'm not sure the latest state of OpenTelemetry, OpenCensus integration, but the OpenCensus packages are read-only in GitHub. We got another comment in chat. Hey, Matthias. And a comment from Alex. Missed a couple of minutes, so apologies if this was answered already, but the OpenCensus views come from metrics generated by components themselves to be reported by the service telemetry metrics. Okay, super cool. Thank you so much for clarifying that. That was definitely something that we were wondering about. So thanks for clearing that up. All right. So it looks like so far the tail sampling processor is probably our best shot. But let's look at this last relatively large frame. And here we can see it's about handling gRPC requests and then unmarshalling these. These are things that would be pretty invasive of a thing to change. There are definitely, I don't know which generators the OpenTelemetry project is using, but this is something that I think, on a stream like this, it's too invasive of a change to do, where this is probably a conversation that needs to be had in the OpenTelemetry project, if that's even the case, right? But there is a pretty cool library from the Vitesse people, which is protobuf VT. Let's have a quick look at that. What is it? Planet scale. Yeah, this one. Let me make that a bit bigger. This is basically an optimized protobuf compiler that generates the Go protobuf code in a more optimized way, and there's more like slice reusing that you can do, and pooling and all sorts of other things to basically prevent exactly stacks looking like this. And then last but not least, what we keep seeing over here is compression being gzip, and there's a very widely used library in the ecosystem by this person, where there are basically faster implementations of I want to say gzip. Yeah, exactly. There's an optimized version of gzip, for example, and there are a bunch of other super interesting compression algorithms in this library. I highly recommend this library. Definitely super cool. Nicholas was asking if we can share the link on chat. Of course, absolutely no problem. That was the protobuf compiler, and then here we go with the compression library. So this could be another thing that we could do, but we want to do code changes on this stream. So I think it's probably we should have a look, but I know for a fact from these function names that this is not using the TESS protobuf compiler, because those would be unmarshal VT. That's the name that's being used there. So if anybody in chat wants to, please feel free to open a conversation, a discussion, an issue on the OpenTelemetry Collector, starting a discussion about should we maybe be using a more optimized version of this, where we can do things like slice reusing, and there's a bunch of expensive memory allocations that are happening here that this optimized compiler tries to avoid as much as possible. Let's see though if there's anything else in here that isn't protobuf marshalling or something that we could have. We could optimize potentially. Over here we can also see compression, so not something that we're going to look at, but again in gRPC it's possible to plug out the compression algorithm, and so we could actually just use a different implementation and still use gzip that is more optimized. But we'll stay away from that for today. Maybe another time we can look into something like that. But now let's have a look at this stack. We can see more tail sampling here. So process traces, and we can see lots of memory allocations here. And this is a good chunk of our CPU time as well, 5.6%. Just this memory allocation is 0.8%. Just this one is 0.5%. So it looks like there is a decent amount in all of this code. And I say it on every stream, but I think it's worth reiterating, especially because we have new folks on the stream, which is really awesome. Thanks everyone for joining. This is not about dunking on anyone who wrote this code, right? Like, code is written in very specific context, and it's very important that we actually do not make premature optimizations. It's important that we only do these kinds of performance optimizations by looking at real production profiling data and making decisions based on that. Otherwise, we introduce complexity in code that may be completely unnecessary, and all sorts of other things. So no, all of this is no comment on the quality of this code. That said, I think judging by all of the data that we have looked at, I think the tail sampling code is going to be where we're going to have the biggest impact. So let's dive into the code. I don't even think that I have, let me do this. I don't think I even have the OpenTelemetry Collector repo cloned. Let me do a cheap trick for a second here. No, I don't. Okay. I'm gonna copy this. So this is how you know there was absolutely no preparation for this stream. I don't even have the repository cloned. Okay, this should be it. I don't even have the repository cloned. No clue if we're going to be successful with these performance optimizations, but we'll try our best. And let me know again if I should change the background music, or if the font is not large enough, let me know. So there were a couple of comments in chat. Adrian was saying, was the profile done on the latest release? Very good question. Actually, let me quickly, let me quickly swing over and check which version this is. I believe we've recently updated this, but let me. That's a very good question. I'll check real quick. And then Alex was saying, and I had to laugh when I read this. This is like the magician showing you that there's nothing in the box. Yes, that's a very, very good analogy. I love that. I'm gonna reuse that. So we are currently using 0.85.0 in production, and that's where this profiling data is from. So, and let's quickly check hotel telemetry. I'll switch back. It looks like we are a tiny bit behind. Looks like there were a couple of minor versions that were created. Let's quickly check if there are any big performance optimizations mentioned. Not in this release. Looks like this is configuration. Wow, it's a lot of stuff happening. Bug fixes, preferred, that looks like a bug fix. I believe there have been no performance optimizations, but we will check the code. All right. So now let's check out this code. We've got the OpenTelemetry telemetry collector contrib repo, and that's where this tail sampling code lives. So we can see it's in processor, tail sampling processor. Processor, tail sampling processor. And I think it's at the, yeah, it's the processor.go file on line 218. Okay, so this looks like it's not accurate anymore. I'm guessing, yeah, I mean, that was the start of the function. So, and I want to say it was the make, yeah, it's make decision. So let's have a quick look over this function and see if we can maybe already spot where the memory allocations are happening. But in any case, we'll do what we always do after broadly trying to understand this code. We will be writing a benchmark so that we can iterate faster on this and also measure what improvement we're actually making. All right, so make decision. We start with our decision being not sampled, and this is an int32. So this is on the stack. This does not escape to the heap. This does not cause a memory allocation. Matching policy. Now this, I don't know yet. We'll see later. Sampling decision. This looks like it could be a culprit. Is this ultimately being returned? Let's see. Okay, interesting. So this appears to be maybe this is a very central thing. So this definitely is going to cause a memory allocation. Maps are always allocated on the heap. And what we can see here is that we basically insert a couple of keys into this and say set fault for each of these. So this may be something that's used throughout the OpenTelemetry project, but it seems like this should be possible to replace this with, you know, something that looks something like this. That is a struct that then has, you know, error, bool, and so on. But we'll see. We will measure if this is actually where our memory allocation is happening, and then we can see. But that could be a way to get rid of a memory allocation like this. Because if we use a value struct, which is essentially what I think this is being used as, then we would not be causing a memory allocation because that is something that stays on the stack. Let's see, check all policies before making a final decision. So maybe at this point, it's worth it to have a quick look at the documentation for this, because I was actually a little bit confused when I was looking at this for the first time. We've got another comment in chat. Is the whole screen showing up on the video? I think I can see the top. Oh, interesting. That's funky. What is it that you can't see? So I'm looking at... Oh, that's weird. I actually have the stream open on my second screen and it looks like it's correct. I did make some code changes, but I then also removed them again because they were just, you know, a tiny sketch. Maybe I was too quick there. Sorry about that. So let's have a quick look at the tail processor. So basically, it has these policies and it can traverse through each of these policies, and then depending on the result of this policy, we make some decision. My understanding is the moment that we end up in a yes, we sample this this span this trace, then we stop and we we say yes, this is something that we want to keep. So check all policies before making a final decision. Maybe I'm wrong already. And Adrian is saying in chat, feels like we spend more time recording the decision in the stats than actually making it. Yes, that is pretty much exactly what I think is happening. Great summary. So we evaluate our policy. We do error handling, and what is this? What does evaluate return? Evaluate returns a decision. Okay, makes sense. And then we check with the switch sampled, if that's the sampling decision, that makes sense. Not sampled, or inversion of not sampled. Okay, I suppose that makes sense. We're not here to change the functionality of any of this. We want to understand broadly how this works so that we can improve the performance. Invert not sampled takes precedence over any other decision. Okay. Now we iterate again over each policy. Trace.decisions works. Okay, trace is one of the values that are being passed in. If it's sampled, if there's any single policy that decides to sample, it will cause the decision to be sampled. The next consumer will get the context from the first matching policy. Okay, makes sense. And our final decision. Yeah, I mean, you know, to me, this looks like what's happening is it's gotta be this map. We definitely will write a benchmark, but basically this is all what's happening in this function itself, and we saw that the memory allocations are happening in this function. This function itself is not really doing a whole lot. It's calling these policies, evaluating the policies, and then evaluating the result of the policies. It's really not doing all that much work. So let's write that benchmark then. Let's see if we can maybe repurpose. What was the function called again? Make decision, I think. Yep, make decision. Let's see if we can repurpose one of the existing. Shame. I was hoping that there was already going to be a just a regular test or make decision. But I suppose we can also just take any of these. Policy inverted, sampling multiple policies. Our configuration is really quite simple. It does not have a lot of policies. I want to say there's a single one that decides whether to there are a couple of calls in our system because it's extremely write heavy, where we sample only 2% of all distributed traces of our write requests, and we sample 100% of all traces of everything else. At least that's the idea. I actually spoke to some folks that said that this configuration in particular may not be working correctly, and I think that is what we're actually seeing in production, but that's another story. We're not here today to fix anything. But point being, our configuration is incredibly simple. So, but we do sample practically everything. So we want to take one of these tests that does sample. Let's sample on tick. Test. Maybe let's start from the top. They're probably the most simple tests. Test trace integrity, test sequential arrival. All right, fine. Let's start with this. So we benchmark, make decision, or benchmark something. I don't know yet. We'll find a better name later. And this generates IDs and batches. A configuration, number of traces, expected new traces per sec. Thank you. I can definitely do that. Actually, I think I can just for now, we can just have this pane open. Maybe I should get a green screen so that the video doesn't cover as much of the editor. Anyway, I digress. Let's replace these first. Now, this ticker frequency makes me a little uneasy. I'm not exactly sure what this is gonna do. Like, I don't really want our benchmark to be like time related to time in any way. Let's see what this does. Consume traces, process traces. Does some stuff. Load or store. Final decision. This is I'm hoping that this actually calls make decision somewhere. I don't see it right now, but yes. No. Where did I? Maybe we can see it from our profiling data. Process traces. Was that in here somewhere? I think it was in here. Yes, okay. So that's kind of what I was afraid of and not exactly what I was hoping for. How can we make sure, does this test make sure that everything has actually gone through? How does this test make sure? Does anybody in chat understand why the test would pass? This is a sync map, so there's something about concurrency happening here, of course. But I feel like there's like a race condition here, no? Process traces and process traces. Append to traces. Aha. We've got an interface here. Consume traces and consume traces. No. But maybe this is still what it is. Consumer. Next consumer is consumer test no op. Okay, so if I'm understanding this correctly, this is actually just not gonna do anything. We probably took the wrong test here. I think all this is doing is it's checking that these traces have been inserted. That's my mistake. We took the second test, right? The test sequential trace arrival. Yeah, I think that's my bad. Test concurrent arrival and evaluation. Okay, I think we should actually just write a test specifically for make decision. I was trying to be lazy and it did not work. All right, so we've got make decision, which wants a p common trace ID, which is if I'm understanding this right, these batches, and we don't really need to. We don't really need this. We don't want a background thing. This is all right. We're gonna want to call tsp.makeDecision. So where does this ID come from? It's part of the batch. Are these batches the same thing? Let's see what this generates. Trace. No, it's not the same thing. All right, so what is this thing then? P common trace ID. Aha, okay, so it's the first thing. The trace IDs. Let's go back to our processor test. So the trace IDs is the first thing. I suppose that makes sense. Maybe we can do this. Trace IDs. Now, not care for a second about the decision itself. Make decision. No, that's TSP. Make decision, and we pass it the ID. And what is the second value? The second value is a trace sampling.trace data. Is that what this is? Traces. Internal traces? No. Doesn't look quite right. Simple traces. Okay, this is not the same thing. So we'll need to figure out where to get that from. And metrics is policy metrics. And that is just something that we can instantiate once. Metrics equals policy metrics. So now we need to figure out where do we get sampling.trace data from. So trace. ID to trace. So it's wherever we interact with this thing and set something to it. Load or store, that sounds pretty good. So when we call process traces, sampling trace data. Okay, this sounds like what we want. I'm gonna copy that over here. Undo this. And it looks like we want to do that per batch, if I'm understanding that correctly. So we want full batches. And then for batch, for each batch we do sample batches equals second sample batches. Let's just add this here. Initial decisions. What are initial decisions? Pending. Okay. I'm guessing we're going to need to define some policies. I think we have. Let's see. Maybe we can get away with not doing this and we can still see everything. Span count is coming from where? Len spans, and spans is ID to span and scope. TSP. Resource spans. What we passed in. Let's see what happens. Let's see what happens. And then sampling. This. What's wrong with this? Sampling trace data as okay, yeah, that's not the right. Sampling trace data. Okay. So now we can do sample batches I. P traces. I thought it does. Oh, interesting. Okay, so we're just gonna do, let's see, maybe this is garbage, but we'll see what happens. All right, now we finally have our benchmark and we can finally run it. So we do our nifty little trick where we ignore all unit tests and we just run our benchmark. We run it for, actually we need to still do something about iterations, and we're gonna want to see some CPU profiling data, and memory profiling data sounds good as well. And we write that to old.txt. Okay, so that did not work, but that's okay. That is probably because we set these fields as unset. So let's first let's do this so that we have multiple generations of our benchmark whenever we run it. And now let's look at this panic. So the panic was on 255. Decisions. Okay, so we want to make it equal length to policies. Whoops. And policy configs test policy as exactly 1. All right. So we want our initial decisions. This is what type again? Just an array of decisions. So it's sampling.decision, and it was pending. So sampling.pending. Whoops. Okay, so let's try that again then. Aha. All right. So we have got our benchmark. Looks like there's a go routine leak. Okay, so something. Are we starting something? Interesting. All right, then let's go back and do these. Let's see if that fixes the go routine leak. Hopefully it does. Yes, it does. All right, cool. Exciting. Now we have our initial set of benchmarks. So let's have a quick look at whether this profiling data looks similar-ish to what we started out with. And we can see here, make decision, and we can see our memory allocations being, you know, a little bit more than a fifth of make decision. Let's filter both of these down to just make decision. So we've got 22% of filtered here, and we've got, okay, it's a little bit less here, but you know, we've definitely got the these memory allocations. This may also have to do, you know, with the version differences, but yeah. I'm curious, I don't think I just saw the record tags. Oh no, it is here as well. Okay. So this benchmark could be useful for all of these stacks actually. All right. Cool. Do we really have to call time now multiple times? That seems unnecessary. All right. Now let's have a look. So we've got our before. Very last thing that I want to do, and unfortunately this feature does not exist yet in pprof.me, so I'm gonna need to pull up the Go pprof toolchain for this one. Because I want to see where the memory allocations are happening. Not this. Make decision. Aha. So this is exactly why we need to measure. It looks like the memory allocations that we're seeing are actually these. The slice that is being allocated here. So it's not the map. Interesting. So maybe there are cases where the map does not escape to heap. I did not know that. All right. It seems like these are the memory allocations that we need to then try to remove. On line 293 and 312. So now I wonder what happens with this thing. What happens with the mutators? So with tags, With tags. Okay, so record options, mutators. Record with options. We create new tags. What happens with mutator here? Okay, so as long as we don't modify the mutators themselves, it appears it's safe for us in this case to reuse this slice. That's great to know. Because what we're gonna do is we're gonna say mutators this, and we're gonna do make. Looks like in all of these cases we only have a single mutator. So what we're gonna do is this, and we do this. What is the issue? Undefined sampling mutator. Nice. Tag mutator. And now this is unused. That is correct, because now the mutators 0 equals, whoops, tag upsert. So these are different for each of these, so do this. Oops. Rude. Oops. Ah. It's all in one line for some reason. Misclicked. Typing is hard today, apparently. Mutators. Okay. Sample key. There we go. Mutator. Okay. Now, I think this shouldn't actually make a difference yet, because maybe it cuts it in half already. We'll see. But I think it shouldn't make a huge amount of difference, because the amount of these slices created are still identical to before. We'll see. We'll see what happens. Right? I believe that already looks a little bit faster, but we'll... So we're already a little bit faster. our sampling decisions are already by 3% faster. But we want to have another look at the profiling data. So we're going to upload the latest profiling data. And we can see that it's definitely less, but it's not all that much less, kind of what we expected. So the question is now, tail sampling span processor. This thing is called with sampling policy on tick. So I want to understand the architecture a little bit here, because if this is not being done concurrently, which I think it is not, but we'll see in a second. If this is not done concurrently, then we can reuse a single slice that we create once for the lifetime of the entire tail sampling span processor. So let's have a look if that's a possibility. Let's check sampling policy on tick. This is the thing that's just being called by sampling policy on tick FM by policy ticker, which is exactly the thing. Let's dig into this for a second. On tick func. So yeah, when this ticks, okay, now all we want to make sure is that for every tail sampling span processor that is created, there's only a single ticker, and that's exactly what we're seeing being done here. Okay, so that's what we'll do then. We will add mutators buff, and I want to say this like tag.mutator, I think, and we'll add a comment. This is for reading this slice by each call of make decision. This was previously identified to be a bottleneck using Papaya. So, hello, Juka, and hello, Diego. Welcome to the stream. We think we found an improvement. We'll see how far we get with it. So, Shuka, since you maintain this, you can hopefully verify that what the statement that I've just said. So it seems like this policy ticker is only here once per tail sampling processor. Therefore, there's no what was it called again? Here. Sampling policy on tick is not called concurrently, and therefore it is safe for us to create the mutator slice once and store that in the tail sampling span collector, and then reuse that on every call to make decision, because in our profiling data, what we had identified was that these lines were basically allocating new slices every time for the tag mutators, and ended up allocating like 2 GB of memory over our benchmarks. And the benchmarks are pretty simple. So it seemed like the right thing to do here. It's tsp.mutator_spa. And we want to make sure that we actually set it. Did we already do that? No. So mutator_spa. And we want to set it to exactly 1 because that's exactly how much we need. We allocate exactly 1 element because that's the exact amount used in any case. Oops. Adrian is asking, and I suppose it's not doable digging deeper into the open census code. We can definitely do that, but typically what we do on this stream is we look at one particular stack where we think we can have a fairly major impact within one stream, and then we can have we can have follow-ups with looking at OpenTelemetry Collector again, where we look at some other stacks. That mutator, so Juka's asking, is that mutator for an internal telemetry? We are deprecating the open census instrumentation in the collector in favor of, well, OpenTelemetry. And yeah, Adrian. Understood. Cool. Cool. So to answer Juka's question, that was for stats.record with tags. So I guess what you're saying is because this is open census, this is actually going away. Interesting. Well, that's context that we don't necessarily always have, but the point of this show is to demonstrate how we can do this, and we don't know when that's going to happen. So until it happens, it's always nice to save some CPU cycles, and then I'm sure with whatever it's being replaced with, we can find some improvements in as well. So all right, I think that's it. Let's see. All right, that's looking a decent amount better, I would say, than our last run already. So cool. So looks like our make decision is now almost 9% faster. Yeah, Shuka is saying, I mean, it's a great improvement anyway, because we'd have the same pattern with OpenTelemetry. Yeah, makes perfect sense. So let's have a look at the profiling data. So we'll pull up the profiling data again. We'll filter it down to make decision. And we can see that we are using, interesting, similar amounts. Maybe there are still more memory allocations. So let's look at the code one more time. So, so it's the tag.upsert that's also causing allocations. So we did definitely improve already quite a bit. That's interesting that that already made so much improvement. Adrian is asking, can the tag.upsert be cached as well? Certainly. It looks like we should be able to just let's just double check that there's nothing like internal that may be being that may be modified or something like that. Internally upsert. No, this looks all good. Yeah, you're exactly right, Adrian. What we're gonna do is we're gonna create two upsert sampled and then not sampled. All right, cool. And we'll replace that with tag insert sample. Juka said, if I recall correctly, we do create the mutators outside of the hot path in other components like the load balancing, exporter, metrics go. It should be doable to just move the upsert outside of the hot path. I'm not sure. Are you trying to say that we should move the upsert outside of this function? It seemed like make decision was the last thing being called in this path. I would say let's finish up our thought here, and then we can figure out if we can refactor this a little bit. So not sampled. All right, so let's run this again. Meanwhile, Juka was saying, yes, like one mutator for sampled equals true and one for equals false. Okay, so pretty much exactly what we've just done. And I think, you know, I don't need to do a comparison to see that this changed pretty dramatically now. We can see that we improved by 31%. Keep in mind, this is only looking at the make decision code path. But we should, I'm expecting that we're not going to see any memory allocations in this path anymore. So let's make decision. Interesting. So we are still seeing something, but we did improve a lot, and I can't really see where. Let's look at the memory profiling. Okay, so memory profiling is definitely now almost exclusively, I mean, we can't see this, so we wanna look at this again. No. Is this causing allocations? Shijuka is saying, I want a PR with that. You shall definitely get it. We still want to see what's going on with this. That would be really curious if removing this removes memory allocations. That would have been very surprising to me if this had made any difference. Michael is saying, I hear future request for Parka Auto PR for identified hot path. Yes, definitely. But it looks like this is gonna happen no matter what. Let's just validate this real quick. Yeah, it's exactly the same thing. Still curious why that is happening. What does record with tags return anyway? Let's first undo this. We don't want to do changes that are not truly necessary. So record with tags returns. I just returns an error. Oh my gosh. Oh. All right. Interesting. All right. Juka is saying, so the cause is likely that it's looking into the context to set custom attributes to the metrics being recorded. Just to prove this, can you use the same blank context there? Welcome to my world. Aha, I think I understand what you mean. You mean the line numbers are basically not exact, and it's these contexts that are being passed around, that because contexts themselves, they are being copied basically. That's why we're generating memory allocations here. Yeah, this makes a ton of sense. Good point. Thanks for mentioning that. Let's just replace it to see exactly whether that phenomenon is what's happening. But that makes perfect sense. Oh, this is why we measure. This is why we measure people. It's not this. Interesting. So Juka is saying it's not being passed around. The information within the context might be used in an open census view. And Adrian is saying, does the profiler show if there's allocations done in the arguments? Stats count traces sampled M thing. So it should show it correctly on each line number. That's how I remember it. And especially if you do a function call, then it's definitely in the debug information. But interesting that this didn't make a difference. I suppose it could be this function call. Like Adrian is saying. But I feel like we've optimized one very specific situation, which is exactly the mutators. So I'm pretty happy with this result. We've made this whole thing about, or this make decision call about 30% faster. Quite happy with that. Adrian is saying, here's the object creation. Well, I think what you're talking about is this, but this is a value struct, which should not, but there are potentially situations where we can't 100% ensure that. This should not create a memory allocation because it's just a value struct. And basically what that means is the compiler can predict exactly how much space is going to be needed to put this on the stack, and therefore may not have to allocate. But there are situations definitely where this could happen. You could be totally right. But we'll leave it to another session. We're happy with these changes. We can see that we've improved by 31-ish%. That should mean looking at our original profiling data, if we optimized about 30% of 20%, that means we have optimized, 6-ish% of our entire OpenTelemetry collector. So I think we can call that definitely a success. Juka saying super happy with this improvement. Thank you. Of course, this is what it's about. I hope everybody learned something, but we definitely still want to open this pull request. So let's copy this. Maybe we can actually separate this out. We first, what was this directory again? Tail sampling processor. Create benchmark for main decision. Now, tail sampling processor. That's quite a mouthful. Adrian saying especially interesting to learn how to write benchmark and do the comparisons. That's awesome. Glad you learned something. Always let us know if there's something else that you've always wanted to learn. We can definitely make scoped live streams where we go into specific topics. Just let me know, and we're super happy to consider it for future episodes. So we remove, optimize mutator memory allocation tag mutator memory allocations. Each instance of tail sampling processor. Now let's make sure we get this right. It's called tail sampling span processor. Each instance of tail sampling span processor are each tail sampling processor instance is not concurrently called by the picker worker. It's a one-to-one relationship. We can safely reuse a slice for the tag mutators used in the decision. Additionally, the tag mutators themselves were causing a lot of allocations. And since they are static, we created constants for them, preventing allocations on each execution of decision. This improved make decision benchmark by sorry, what did you say? 31%. All right, there we go. Mutator Alex. I don't think I have this repository forked, so let's do that. Adrian's saying after Hacktoberfest we should have a profile test. I'll let you all in on a tiny little secret. We're actually already preparing for exactly that. So keep an eye out on Twitter for when it goes out. And Adrian was also saying, but I guess for maintainers, it may be quite hard to receive a flood of PRs on some perf optimizations. I suppose it's a balance of gain versus maintenance. I guess that's the same thing for Hacktoberfest. And one of the complaints for Hacktoberfest is often that the quality of changes tends to be quite low. Maybe, you know, this kind of initiative increases that, right? We'll see. And Juka is saying, I'll take as many PRs as I can get, provided they come with benchmarks proving the improvements. Exactly. I completely couldn't agree more. So let's fork this thing. Oops. Since when? What just happened? It really not. I don't think I've ever seen renaming an origin doing something. Looks like it's a large repository. That is a big repository. And we're uploading at 5 megabytes per second. Juka saying, while you wait, have you played with the GitHub CLI? Forking and sending PRs from the CLI is always better with GitHub. Actually, I've not played with it. Maybe we can do that in a future episode. And then Alex was saying, we do have Contrib Fest at KubeCon. Yes, definitely participate in those. Maybe we can run a session on optimizing Kubernetes. I would totally be up for doing that. If you want to make it happen, Alex, shoot me a DM on Twitter, and we can try to make something happen. All right, so now I guess we can just take our here we don't have this. Unit tests unchanged, added a benchmark. Perf improvement, so no communication needed. And then we'll be a nice citizen and say this was all based. This was all based on production profiling data, polar signals. running the collector. Here is a snapshot of the original profiling data. We started with the profiling data after doing here we go. And then finally, this improvement was done as part of that profile live stream where we optimize popular open source projects live. All right, cool. Let's open, and I guess we've got Juka who's gonna sorry, Juka said you need a changelog entry as well as a new file in .changelog directory. All right, let's do that. .changelog. All right. Okay. Thing. Let's check. And we did optimize fail sampling processor, and we can use our PR number, it said. Optimize performance of fail sampling processor. Guess this is fail sampling processor. Right, was that the file name? Shuka's saying there's a template YAML there. I did not see that. I suppose we're enhancement. Okay. Looks like we did not commit a crime. All right, cool. All right. Cool. Looks like this is it for this. Actually, I want to record. So if we made make decision by 31% faster, judging by the production profiling data, 31% improvement on the make decision code path should translate roughly into a 6% baseline CPU improvement on our production deployment of the OpenTelemetry Collector. I say this specifically because, of course, this one depends on tail sampling actually being enabled, and I understand not every production configuration necessarily has that enabled, but we do. So that's that. All right, cool. Definitely a very successful stream again, I would say. With that, like I said, please like and subscribe. It really helps us with the channel. And let us know in the comments, in chat, on Twitter, wherever you want. Let us know what you want to see next, what you want to have profiled next, what you want us to investigate next. And with that, have a wonderful weekend. Hope you have a great rest of your Friday, and happy profiling. Thanks, everyone. See you next time.